everyone, thanks for attending today's video session. We're going to be diving into Snowpark and using Immuta with Snowpark to simplify data access controls with your ETL pipeline. So let's get right into it. So first thing we're going to take a look at today is we're going to jump into Visual Studio Code where I've installed Snowpark. We're going to load some satellite data, look at it, build policy for that satellite data, all from a single notebook, all using Snowpark. So let's get started. So I'm going to go ahead and log in to Snowflake and Immuta. So as part of the directions to get this up and running, you have to have Snowpark enabled in your Snowflake environment. In this case, it's already been done. But essentially what I'm going to do is I'm going to read some satellite location information that's been captured from a website called n2yo.com. They have an API you can call to get information about where satellites are located in orbit. And here's an example of that data set where you can see the name of the satellite, the position, latitude, and longitude of that satellite, as well as the timestamp in which the satellite was orbiting in that position. So what we're going to do is we're going to load this to Snowpark using the Snowpark API, Python API. And in this data set, there are 16.5 million satellite positions in the data set. So essentially what I'm going to do is I'm going to use a create data frame function inside of the Snowpark for Python library. And I'm going to tell it to create a data frame from this file. And so what I've done here is I've actually already loaded this data. So you can see now I'm actually running this count function on top of a Snowpark data frame. And essentially now what this means is anytime I do these operations, I'm actually querying data directly in Snowpark without having to move it to my client where this Jupyter Notebook's running. And so here you can see I can do a couple things like get the schema for the table. I'm also going to define some tables that I'm going to use later to load data into Snowpark and do some ETL. And so here I've actually already done the drop and cleanup, so we're going to recreate all this stuff. So I'm going to go ahead and save my data frame that I've loaded into Snowpark as a staging table, and then I will actually set my context for the staging table so I can check my variable, my number of rows here. So now that I've staged this 16.5 million row points, I'm going to do some cleanup, deleting some bad rows that I accidentally loaded in this data set. And so all of this information is in this notebook, which will be shared at the end of this video. And then the next thing I'm going to do is I'm actually going to do a join using a spatial operator called st-intersects with a polygon table that contains city polygons. And so what we're going to do here is this is going to give us the ability to do filtering on the data set so we can know for any given satellite position where is it actually orbiting in the world. And so we'll do a left outer join between the satellite location table and the city polygon table, so that way we get nulls back anytime a satellite is orbiting over an ocean or just a specific region that doesn't have a city polygon, so we know which, the International Space Station was over Oklahoma or over Tulsa County in this specific time frame, so you can start doing filtering and building unique policies there. We're also going to get the polygon ID back in case there's ever a use where we need to actually draw these polygon objects in some sort of client application. And so that's what this SQL statement's doing here. And so after we've done this, we're going to clean up the data, running those deletes, and you can see there's a million bad rows, and that's just my fault the way I was collecting the data originally. So now you can see there's 15.4 million rows, and now we're going to geo-enrich that by adding this polygon shapefile. So here's the example polygon shapefile, and it actually has a geometry field. In order to load this into Snowpark, I'm actually going to convert it to something called WKT, which is just well-known text. It's a text representation of a polygon's geometry. And so here I'm doing all of that, and if you look over on the right-hand side of my data frame output, you can see now we've converted this into well-known text. And so I'm going to again use the same Python Snowpark API for create data frame, which is going to upload this to Snowflake. And now that I've done that, I'm writing this table out to a staging table. And so after this is done, we can confirm what this looks like by running the schema function on top of the Snowflake data frame object that I've created. And after this, I'm going to do some cleanup where I convert the well-known text to an actual geography data type inside of Snowflake. And so you can see that's exactly what I'm doing here. And so here you're getting the additional country codes on this particular row now. So when we need to do segmentation based on either whether it's a country or a city, we have the information for at this specific point in time, the space station was orbiting over in Germany. And you can use that now to do some further analysis if you want to color code by a specific region to see how often the International Space Station orbits that or whatnot. So then we're going to create some classification on this so we can show how Immuta will quickly allow us to build a policy based on the type of data we have. And so once I've done that, let's go ahead and take a look. Here again, you can see a different set of rows where this one's over the United Kingdom. I also see one where we're actually orbiting over some place in the world that doesn't actually have a city polygon, so the left outer join is working correctly there, giving us back nulls on that particular instance. And so now what I'm going to do is I'm actually going to plot this in a client library using a bunch of different libraries here, but essentially what this is going to give us the ability to do is look at the data set. And so here we're looking at, I think, 5 million roughly points of the satellite position orbiting over the Earth. And so you can see it's just repeating the world. But if I zoom into this, you can see some of the really interesting patterns. So the overarching sine waves are actually the International Space Station orbiting the Earth. And then what we're going to do now is we're going to actually tell Immuta to protect this table and see how it updates the output here. And so the first thing I'm going to do is clean up my staging tables. We no longer need those, so I'm telling Snowpark to drop those. And then I'm going to register this table with Immuta. And so what's going to happen now once I register this table is Immuta is going to start scanning the data for sensitive data as well. But we're also going to be able to build a really interesting policy that's easy to understand that will get people access to this database, and so, or to this table. So what we're going to do now is we're actually going to look and see who currently has access to this satellite table. And what you'll see here in this function I'm calling for get Immuta source access is that my admin that's just registered the table in Immuta is the only thing that has access. So we're going to build a subscription policy here that allows users to essentially access any table that we find a satellite name tag in Snowflake on. We're going to give them access to view it in Snowflake and be able to run queries. So what happens now is I'm going to set this Immuta policy, and what's going to happen here is now my user can actually run a query to see which users in Snowflake are going to have access. So you can see now, in addition to my user that was the admin, we can see that there is a user that has been subscribed based on that policy that we just set. And so again, this is looking at user profiles. It could look at role membership. It could also be a specific reason. So people have to agree to use data for a certain reason to be able to see the data here. And so next thing I'm going to do is I'm actually going to just double check what that policy looks like. So I'm asking Immuta, hey, what are the conditions for this subscription policy? And you can see I have to be in a Department of Space Exploration. And so now the next thing I want to do is build a policy that filters out data based on a satellite name. So inside of Immuta, I actually have Okta set up with my user profile. And on my user profile, those users have specific satellites they're allowed to see. And so in this case, I'm going to go ahead and create this policy that's going to say, hey, only allow users to see the satellite name that matches that satellite name on their user profile. And so now what we'll see is once I set this policy, we can go take a look at how the data is actually changed. So as I run my query as a user that's only authorized to see the space station, I'm going to call Snowpark directly here, and now you'll see all the data is actually limited to the space station. And now what's really interesting here is we can go rerun this view to see what that looks like after the policy's been set. Now you can see the user, after we set that policy, has the space station only in the data set. And so if we zoom in again, now you're seeing just the pattern of the space station over time orbiting the Earth. And there's very interesting overlapping sine waves here because this is a historical data set. It has a lot of data in it. And this is kind of what the purpose of using Immuta to build these really scalable policies is. And so this is a high-level overview of what Snowpark does, makes doing ETL work very easy, and I hope this example with Immuta highlights how you can actually build policy that moves along with your ETL pipeline, making it easy to understand, version control. For more benefits around Immuta and how we really reduce the complexity of access policies and security policies in Snowflake, feel free to check out the description where there's going to be some more information around how you can get more details on the technical implementation of that. Thanks so much for watching. I hope you found this video useful.